warahmatullahi wabarakatuh. Welcome grade 8. Today inshallah we are going to revise what we already studied in the second term. We will start with the algebra. So first of all we studied in the first unit factorization, and you have many lessons in factorization. So first of all, to know how to factorize an expression, first we need to take the common factor. If there is any common factor between the three terms or the four terms in the expression, so we have to take the highest common factor for them. Then we need to determine the type or which method we are going to use to factorize this expression. Like here we studied some types of factorization, like difference between two squares, sum or difference between two cubes, completing the square, like the perfect square. Here we have the perfect square, and then factorization like in this form here, x power 2 plus bx plus c. We call it the simplest form, and the complex form, which is ax power 2 plus bx plus c. And finally we have factorizing by grouping. We already studied this at the end of the term. Then we are going to talk about each one of them separately. Here we have to know first of all how to take the highest common factor. Like if we have AB plus AC, then the common factor here is A. Letter A is repeated in both the two terms here, then I can take it outside as a common factor. Like we have expressions like this here. We have 6x power 2y plus 10xy to the power 2. What is the common factor between them? I noted that both the two numbers here are even numbers. Then they both are divisible by 2. Then I will check if they are divisible by any more numbers. No, they are only divisible by 2. So we take 2 as common factor. Then I look at the letters, letter by letter. So here we have x power 2 and x. Take the lowest power here for the letter. We have x power 2 and x power 1. So I take x as common factor. Then I have y and y to the power 2. The lowest power here is y power 1. I take y as common factor. Then divide. 6 divide 2 equals 3. X power 2 divide x equals only x. And y will be cancelled with the y. Plus 10 divide 2, which is 5. X will be cancelled with the x. Y power 2 divide y will be y. And that's the solution here. So 2xy is the highest common factor for this expression. And in the bracket here we have 3x plus 5y. Then another expression like this one, the highest common factor will be a bracket. As you can see, x plus y here is repeated. This is the highest common factor between the two expressions. The remainder here is only 2a minus b. Then this is how to take a common factor. The second part here, if we have difference between two squares, like a power 2 minus b power 2. The meaning of difference between two squares, both the two terms you can find their square root. And factorizing it like here, like x power 2 minus 9, it will be factorized as x multiply x and 3 multiply 3. And one of them will be with positive sign and the other will be with negative sign. So it will be x plus 3 and x minus 3. Also, if you have x power 2 minus 25, it will be the same. Two brackets, and you have x and x, 25 gonna be 5 and 5, negative and positive. There is no any difference if you change the sign here or switch the sign. But if it's x power 2 plus 25, we cannot factorize it. It's not factorized. Here also you have 16x to the power 4 minus 81. It can be factorized as 16, it's a square root, 4 and 4. X power 4 gonna be x power 2, x power 2. 81 will be 9 and 9, negative and positive. The two brackets here. But if you notice here, this bracket is sum of two squares. As I told you, it's not factorized, but this one is difference between two squares, which can be factorized one more time. It will be 4x power 2 plus 9. We will just keep putting it. And here factorize 4x power 2 minus 9. 4 gonna be 2x multiply 2x and 9, 3 times 3 and negative and positive. So here if we have an expression like this one, I noted that they both have common factor between them, which is 2, because 72 is also divisible by 2, and x power 3 and x, there is a common factor between them is x. So we took 2x outside as common factor. Then the remainder here is x to the power 2 minus 3x. Factorizing it as two brackets as we said, x and x, 36, its square root is 6. So it will be positive and negative, 6 and 6. So first of all, we needed to take the highest common factor. The next type here, if you have sum of two cubes. Sum of two cubes or difference of two cubes, they both can be factorized as small bracket and big bracket. Cube root of the first and then cube root of the second with the same sign. Cube root of the first is A, cube root of the second is B with the same sign here. If it's difference of two cubes, okay, I will do the same. Cube root of the first, cube root of the second with the same sign. The next step here in the big bracket, I take the first to the power 2, take the second to the power 2, put it at last, and both are positive here. And then multiply first by second with opposite of the sign. Put it in the middle term. Here also we are going to do the same. A will be here a to the power 2. B also will be b power 2. As I told you, they both are positive terms. In the middle here, it depends on the middle sign. If it's negative, it will be positive. Multiply the first by the second. That's it. For example, here we have x to the power 3 plus 8. How to factorize it? Okay, cube root of the first is x. Cube root of the second, which is 8, is 2. With the same sign, which is positive. The next step, take the first power 2. X will be x power 2. 2 will be positive 4. In the middle, first times second with opposite of the sign. It will be negative 2x. The next here, before factorization here, we need to take a common factor. So 3 and 81, they both are divisible by 3. Here we got the 3 outside. X power 4 and x, there is x between them as common factor. Y and y to the power 4, it will be y as common factor. I take the lowest power, as I told you. Then the remainder here is x to the power 3. And we took y already. Here it will be negative 27 and then it's y to the power 3. Now it's time to factorize it as difference of two cubes. Keep 3xy outside and then open two brackets, one small, one big. X to the power 3, its cube root will be x. 27y to the power 3, it will be 3, yes, y. With the same sign, don't forget that. X to the power 2, yep. 3y to the power 2, it will be 9y power 2. Don't forget it's positive. First multiply second with opposite of the sign. It will be positive 3xy. And that's the factorization of an expression like this one. Another form here, trinomial in the form x power 2 bx plus c. As I told you, it's called the simple form. With no coefficient here for x power 2, it is the simple form. How to factorize it? Here we have x power 2 plus 7x plus 12. Okay, to factorize an expression like this, we open two brackets. X power 2, x and x. 12, okay, we will think. 12 can be 1 multiply 12 or 2 multiply 6 or 3 multiply 4. I have all the factors of 12 here. Which one I will choose? I will get the 1 or the 2 of these, which their sum gives me 7. Which 2 of them, their sum equals 7. Okay, their sum equals 7, not 1 and 12, not 2 and 6, it's only 3 and 4. I will put 3 multiply 4. What about the sign here? If the last term is positive, they both will be like the middle. If the last term is negative, like the second one here, the greatest will be like the middle and the other will take the opposite sign. Here, if there is minus at last, then I need two numbers, their difference equal the coefficient of the middle term here. Their minus should be 1 as here. So their minus equal 1, yes, it's 3 and 4. I put them and put the sign according to, if the last term is negative, the greatest like the middle, the other will be with the opposite sign. Then another form here, which is the complex form, when we have a coefficient for the first term here, x to the power 2. Then, for example, we have 6x to the power 2 plus 7x plus 2. How to factorize it? we have to get all the coefficient, the factors of the first coefficient here and the last term here. It have to be ordered. It have to be organized. It should be arranged according to the power, greatest then smaller than smaller. Don't forget that. So here we have 6. 6 can be 1 multiply 6 or 2 multiply 3. 2, it only can be 1 multiply 2. Okay, open the two brackets and start to factorize it. I will try to choose 1x, which can be written as only x, or 1x, it's okay. 1x multiply 6x. And 2, it can be 2 multiply 1. I need to know if the middle term will be 7 or not. Their sum should be 7. 1 multiply 1, it's only 1x. 2 multiply 6, it's 12x. Their sum, not 7. Okay, so we are going to switch them. Switch here means I will put the 1 here and 6x in here. This is the way or the method how to solve a question like this one, how to factorize it. 6 multiply 1, it's 6x. 2 times x equals 2x. Their sum is not 7, it's 8. So now I know that it's not 1 and 6. This is not the right solution. I will try 2x multiply 3x. 2 multiply 1 equals 2x. 2 multiply 3 equals 6x, yes. And their sum is not 7 also. Then, yeah, I will switch them. But here 3x and here's 2x. 3 times 1 equals 3x. 2 times 2, yep, it's 4x. Their sum equals 7. Then, yes, this is the right solution. The last term is positive, then they both will be like the middle. They both will be positive. Let's see another question here, and it's also have a common factor before we start. Focus on this. 36, 84, 15, they all are divisible by 3. Then let's write here. We will divide all the numbers here, or the 3 numbers, by 3. Take 3 outside. Then they all have x as common factor. The lowest power here is 1, so it will be 3x to the power 1. 36 divide 3, yep, it will be 12. X power 3 divide x, it will be x power 2. Minus, because it's here negative, 84 divide 3, it will be 28x. X power 2 with x, it will be x. Negative 15 divide 3, it will be negative 5. And the x is cancelled with the x. The next step, 3x, and then open the two brackets. 12, okay, 12 can be 1 multiply 12, 2 multiply 6, and 3 multiply 4. What about 5? 5 is the prime number, it's only 1 times 5. So I can just start by putting it here, 1 multiply 5. And then I will switch these numbers here. So 12 can be, let's try 1x multiply 12x. 1 multiply 5 is 5, 1 multiply 12 is 12x. If their difference equals 28, that's not true here. Then we will switch their places. I'll put the 12 here and the 1 in here. 1 multiply 5 is 5, 1 multiply 12 is 12. Their difference also is not as 28. Then let's switch them. 12x multiply 1x. Yes, 12 multiply 5, it's 60x. And 1 multiply 1, it's 1x. Then here, yeah, their difference is not 28. So it's not the correct answer to use 1 and 12. Then I will cancel it. Now I have 2 and 6. 2 times 5 equals 10. 1 times 6 equals 6. Their difference is not 28. Let's switch them. Put the 6 here and the 2 in this part. And then let's try. 5 multiply 6 equals 30. And 1 times 2 equals 2. Here their difference, yes, it's 2x and 30x. Their difference is 28. Okay, how to get the sign is negative here in the middle? Then the greatest one should be the negative sign. Which one gave me the greatest here? Multiplying 5 by 6. This will be like the middle, the other will be with the opposite sign. So the final answer here is 3x multiply 6x plus 1, 2x minus 5. Another form of factorization here, the perfect square trinomial. The perfect square, it's like 3 terms, and the first the third should be positive, and factorizing it is like this form here, 1 bracket all to the power 2, square root of the first plus or minus square root of the third. Okay, for example here, like x to the power 2 plus 10x plus 25. How to factorize it? It's a perfect square because you can find square root of the first, square root of the third, and if you multiply them by each other by 2, it will give you the middle term. So yes, it's a perfect square, and its factorization, 1 bracket to the power 2, square root of the first, which is x, square root of the third, which is 5, with the sign of the middle term. Okay, what if I have a missed term in the three terms here? Let's try to get first of all, let's get the middle term. As we just did it, it will be positive or negative. It's always positive or negative. 2 multiply square root of the first term multiply square root of the third term. This is how to get the middle term. What if I want to get the first term? Okay, the first and the third term, we got them using the same method here. So I will put the middle term all to the power 2 divided by 4 multiply the third term. Because I need to get the first, I will multiply by the third. Okay, what if I need to get the third? I will do the same. The middle term to the power 2 divide by 4 multiply the first. And that's how to get the middle, the first, and the third term. These rules will help you to get them. Like here, for example, let's say here this term is missing here, 24xy. To get it, I will get the square root of the first here, which is 3x. Square root of the third here, multiply by 4y. Multiply all this by 2. 2 times 3 times 4. 3 times 4, it's 12. Multiply 2, it's 24xy. That's it. And it should be positive or negative. If I pretended here I don't have the first term, let's use the rule to get the first term. Okay, getting the first term here, I will get the middle to the power 2. It will be 24 power 2 multiply x power 2 y to the power 2 over 4 multiply by 16 y to the power 2. You will try to divide this y power 2, cancel it with y power 2, and dividing 24 power 2 divided by 4 multiply 16. Then using calculator, yes, it will be 9. So dividing these numbers here together, it will be 9. And the remainder here is x power 2. As you can see here, it's 9x to the power 2. So let's try another form here, talking about the factorization by grouping. Grouping means you will divide each two terms together as groups. Like here, like when we have ax plus ay plus bx plus by. I can take a common factor between these two terms, which is a, multiplied by x plus y. Here also I can take b as common factor. It will be x plus y. Then I can notice now the bracket x plus y is a common factor outside, and then the remainder here a plus b. What if I have an expression like this one, like x power 2 minus 2xy plus y to the power of 2 minus 9. Here I can't divide it as two terms and two terms. It can be divided here, it can be divided as three terms minus the fourth one. The fourth one will be minus here, the one which have a negative sign here, and the other three terms will be factorized as a perfect square. Then open a big bracket here to the power 2, square root of the first, square root of the third, with the same sign of the middle here. That's how to factorize this part. Minus 9. Now I converted it to be difference of two cubes. So when you have an expression like this, three terms, they look like related, and the fourth one is not like them. Doesn't have anything related to them. I can make it as difference of two squares like this. After that, factorize it as difference of two squares square root of the first x minus y and x minus y, square root of the second here, 3 and 3, one of them negative, the other is positive. That's all about factorization here. Then let's try to talk about solving quadratic equation in one variable algebraically. It's depending completely, 100% completely here on factorization. So like that, if you have x plus 5x minus 3, it was already an expression, you factorize it to be in this form. The next step after factorization, we already talked about factorization. After that, now we can use this expression here to solve it as an equation. I will take it as x plus 5 here equals 0, because in multiplication, if their multiply equals 0, that means one of them may be 0. I don't know which one. Then I say that x plus 5 equals 0 or x minus 3 equals 0. Take the 5 here outside, it will be x equals negative 5, and here x will be 3. Finally, you have to write the solution set, which is now negative 5 and 3. Here, after factorization, you get this form. Then what? I will separate it like x alone equals 0 or 2x plus 7 equals 0. Here, I can't do anything anymore here, but here I can get the 7 outside, then 2x equals negative 7. Then divide by 2 to get the value of x. X will be negative 7 over 2. And here is the solution set. At last, we have 0 and negative 7 over 2. That's how to get the solution set. So here, in any expression or any equation in this form, the solution set will be equal to the two letters here, or x will be this L or x will be this M. That's the solution set. Let's see another part here. If you have an equation like this, ax power 2 plus bx plus c equals 0, then you have to factorize it. And before factorization, you have to put it in this form, the standard form. All the three terms equal 0. Like here, like this one. It's already put in the same form we need. Now I can easily factorize it. All equal 0. X and x. I need to number their multiplication equals 6, their difference equals 5. Yes, it's 6 and 1. And since it's minus here, the greatest will be like the middle, the other will be with the opposite sign. Now, as we said, x minus 6 equals 0 or x plus 1 equals 0. Get it outside here to get the solution, x equals 6 or x equals negative 1. Now, the solution set, finally, will be like 6 and negative 1. What if the equation is in this form? Yes, in this form here, get the 6 inside, don't keep it outside. And also distribute the x in this bracket here. X multiply x, x power 2. X multiply 1, negative x minus 6, it will be 0. Now it's the normal form as we used to talk about it. So now I can start factorization. I need two numbers, their multiplication equals 6 and their difference equals 1. Yes, as you are thinking here, it's 2 multiply 3. The greatest will be like the middle because the last term is negative here and the other one will be with the opposite sign. Then we have to get the solution for it. X plus 2 equals 0 or x minus 3 equals 0. Then now x equals negative 2 and here x equals 3. Then the solution set will be negative 2 and 3. That's it. Then we are going to talk now about the second or the other part of solving equation. The second part of solving equations here, it's about the applications using the equations. The applications here, we are going to tell you like a story problem or like a word problem, and you have to solve it using equations. But first of all, you have to recognize what the meaning of the expressions you can find. Like a number x, for example, and it's half. So the number will be x, its half will be half x. It's twice 2x. It's a square x to the power 2. And so here in in its third it will be third x. 3 times it will be 3x. Its square, twice its square, it will be 2 multiply x squared. Square its double, so you have to get first its double and then get its square here. So it will be 4x power 2. The additive inverse of the number, change its sign, and the multiplicative inverse of a number, flip its the fraction for this number, flip it. Two numbers, one of them exceeds the other by 5. That means if the first number is x, then the other exceeds it by 5, so add 5 to the other number. One of them less than the other by 5, I will use the same expression here. Then also you have the sum of two numbers equals 5. Okay, then the first may be x, then the second will be x, 5 minus x. Subtract x from the 5. Two numbers, one of them is more than twice the other by 5, so x, the other will be 2x plus 5. Here are some expressions, you have to revise them. 3 consecutive integers, x plus 1, x plus 2, these are the three numbers. If they are odd or even, x plus 2, x plus 4. The two numbers, the ratio equals 2 to 3, one of them 2x, the other is 3x. Age of the man now is x, then after 4 years you add 4 to the x, 3 years ago you subtract 3, and square of his age 6 years ago, so you first get his age 6 years ago and then get its square. A rectangle whose length exceeds its width by 5, then you suppose that the width, the smaller number is x, then the length will be x plus 5. You can use these dimensions now to get the perimeter and the area of the figure here, or the rectangle. The perimeter, don't forget that, length plus width all multiply 2, and the area you multiply length plus length multiply width. The square its side is x, then the perimeter will be 4x and the area will be x to the power 2. Let's study the second unit here, the laws of integer power in R. You already studied the powers in the previous year and the previous and in grade 6 also, in grade 6 and grade 7. Then you of course remember that in multiplying two numbers with the same base, we should add the power. It will be a to the power m plus n. If we are dividing them, then we have to subtract the power. If we are going to multiply the numbers and they have all the same number at the same power, I can distribute the power for each one of them, and also I will do the same if I am dividing the two numbers. Like here, 4 to the power 3 multiply 4 power 2, it will be 4 to the power 3 plus 2, which is power 5. Dividing them, subtract the powers here, which is 3 to the power 4. Like 3 multiply 4, all to the power 2. Also, we can use this in some exercises, as you noticed in studying this lesson. For example, if you have already 12, all to the power 2. 12 to the power 2, I can make it as 3 multiply 4 all to the power 2. And then divide the power with both of them, the 3 and the 4. Here also did the same with dividing, divide the power for each of them. Power of the power, we can switch them, don't forget that. And also we can multiply them. 4 to the power 2 all power 3, it can be 4 to the power 3 all power 2, and also we can just multiply the powers, which is 4 to the power 6. Some important informations here, don't forget that any number to the power of 0 except 0 equals 1. And any number to the power of negative number, I can just flip the number here, make it as 1 over, get the reciprocal of the number 1 over a to the power n to make the power positive. Here also, if the power is negative, I can just flip the fraction here, reciprocal of the fraction will make the power positive here. Like as you can see, any number power 0 equals 1, in negative power it can be positive here, and divide also in fraction you can make the power positive. Let's study the first example here. We have root 3 to the power of 7 multiply root 3 to the power negative 9 multiply root 3 to the power 4, we need to find it in the simplest form of each of the following. So first of all, I have the same base for all the three terms here. We have the same base, so it can be root 3 to the power 7 plus negative 9 plus 4. That is the most easy way to find the result here. So now it will be root 3 to the power 7 plus negative 9, which is negative 2, plus 4 equals positive 2. Now root 3 to the power of 2 equals only 3. In number 2 here, we have root 2 over root 2 to the power negative 2. As I told you, if I want to change the sign of the power, just change its place. If it's in numerator, put it denominator. If it's denominator, put it numerator. Now it's in denominator. Okay, we put it out. So we have root 2 multiply root 2 to the power of 2. Root 2 here, it's like power 1. Now I can just, in multiplying, I can make it as power 3. Or easily we can find the value for this one, which is only 2. It will be 2 root 2. Let's see here number 3. We have 2 root 5 multiply root 3 all to the power negative 2. Okay, I can just flip it to make the power positive. It will be 2 multiply root 5 multiply root 3, which can be written as 1 over 2 root 15. Okay, we can make it simplest as you learned this in the first term by multiplying by this root up and down, root 15 over root 15. Then, in multiplying here, it will be root 15 over 2 multiply root 15 times root 15, which is 15. Now, I have the result will be root 15 over 2 multiply 15, which is 30. And this could be the simplest form for this expression here. You already learned how to do it in the first term. Let's see here number 4. I have 3 root 2 over root 3 all to the power 4. Yes, I can easily distribute the power for each one of them. Make 3 to the power 4. Multiply root 2 all to the power 4 over root 3 all to the power 4. And that's it. Get the 3 to the power 4 here. So it will be 3 power 4 equals 81. Multiply root 2 to the power 4. It's like root 2 multiply root 2 multiply root 2 multiply root 2. Then it will be 4. Yes. Over root 3 to the power 4, it will be 9. And then we can easily simplify it now. 81 divide 9 equals 9. And then 9 multiply 4 equal 36. Let's see the last one here. Root 3 to the power negative 2 all to the power 2. I can solve it with many methods, but I'd like to make it as root 3 all to the power multiply the powers. Negative 2 times 2, it will be negative 4. And then we can make it as 1 over root 3 all to the power 4. Now, get the value for root 3 power 4. We just did it here. It was 9, so it will be 1 over 9. Let's see another example. Find each of the following to the simplest form. Root 3 multiply 2, root 3 power 2, multiply negative root 3 to the power 5 over 2 root 3 to the power 4. Okay, the first step to solve it here, I will distribute the powers here to know each root 3 with which power. And then I can add the power together in the first one. And I have here root 3 multiplied by distribute the power. 2 power 2 equals 4. And we have root 3 power 2 multiply. Oh, the number here is not positive root 3. It's negative root 3. And negative root 3 with power odd, not even, we will keep the sign, but keep it outside. And then we have root 3 all to the power 5. Over, distribute the power, 2 will be power 4, multiply root 3 to the power 4. Let's try to make it simplest now. Root 3 power 1, root 3 power 2, root 3 power 5, adding them, 1 plus 2 equals 3, plus 5 equals 8. Now I have negative 4, multiplied root 3 to the power of 8, over 2 power 4, okay, 2 times 2 equals 4, 4 times 4 equals 16, yep, easily. Here I have root 3 all to the power 4. Let's divide and let's make it simplest here. Negative 4 divide 16, keep the negative up, and here 4 divide 16 here, 16 divide 4 equals 4. And in dividing, we have to subtract the power, then it will be root 3 to the power 4. 8 minus 4 equals 4. I can get its result here. Root 3 to the power 4. Yes, we got it. It's 9 over 4. Then the final result will be negative 9 over 4. Let's see example number 2. We have here root 18 all to the power 5 multiply root 2 power 3 over root 12 to the power 4. Okay, if you remember in the first term you studied how to make root 18 in simplest form. We used to make it as root 2 multiplication of two numbers, one of them have square root. Like 2 multiply 9, yes, get the 9 outside, will be 3 root 2. And that's what I'm going to do here. It will be 3 root 2 all to the power 5. Multiply root 3 to the root 2, to the power of 3. Down here we have root 12. Okay, root 12 also can be done with this method. 12 can be 3 multiply 4. Yes, I took this because 4 have square root. Get it outside, it will be 2 root 3. Now I can make it as 2 root 3 all to the power of 4. Now I will just remove this here. Try to solve it now. I will distribute the power here. So I have 3 to the power 5 multiply root 2 to the power. Root 2 will be power 5 and it already have power 3 here. Then adding the power, it will be power 8 over 2 power 4 and root 3 to the power of 4. I can easily solve them together here to get the final result. Root 8 to the power, root 2 to the power of 8, it will be like root 2 multiplied itself 8 times or 2 multiplied itself 4 times. Try to check this. Then it will be the same like 2 to the power 4. And then now I have 3 to the power 5 over root 3 power 4. Root 3 can be root 3 power 2 all power 2. Root 3 power 2, because here power 4, I will make it as 2 times 2. Root 3 power 2, it's 3. That's why I did this form. Here it will be 3, all to the power of 2. Now I have it easily now. Without using calculator, I can solve it. In dividing, subtract the power. 5 minus 2 equals 3. 3 to the power 3 equals 27. This is the same method I used when I tried to cancel this one with this one, because also I made it as root 2 to the power of 2 all to the power of 4. Because root 2 power 2, it will be 2. 2 power 4, yes, it will be the same as this 2 power 4. That's why I canceled them together without using calculator. But if you use calculator, it will help you, of course. Then let's see another example here. We have to simplify to the simplest form. 2 to the power 5n multiply 3 to the power 2n plus 1 divided by 4 to the power negative n multiply 6 to the power 2n plus 1. Okay, how to solve it? If you have a number with negative power, okay, put it up in the numerator. If it's in the numerator, put it in numerator. To make all the powers in the exercise positive. Now I have it here. 2 to the power 5n multiply 3 to the power 2n plus 1 multiply. Can we make this 4 as 2 or 3 to any power? Yes, I can make it as 2 power 2. And it already have power n now, it's positive, not negative. We make it up over 6. 6, it's a number, can't be written as a number raised to a power. But I can make this 6 to be multiplication of two numbers. For example, 2 multiply 3. They are raised to the power 2n plus 1. So I will distribute the power for each one of them. 2n plus 1, 2n plus 1. Will it help me here? Yes, of course. I will use it here to cancel 3 to the power 2n plus 1, 3 to the power 2n plus 1. I have here 2 to the power 2n, 2 to the power 2n plus 1, and 2 to the power 5n. Okay, I can just add the power up, 5n plus n, it's 7n, and here 2 to the power 2n plus 1. In dividing, we subtract the power, then it will be 2 to the power 7n minus 2n minus 1, subtracting the powers. 7 minus 2 equals 5, so now it will be 2 to the power 5n minus 1. And this is the final answer here. But he said that find the value of the result when n equals 1. You will say that at n equals 1, I will just substitute here 2 to the power 5 multiply 1 minus 1. 5 multiply 1 equals 5, 5 minus 1 equals 4. Now it will be 2 to the power 4. And 2 to the power 4 equals like 2 multiply 2, which is 4. 4 multiply 4 equals 16. That's it here for this example. And then we are going to study solving the exponential equation in R. Exponential equation means it's an equation, algebraic equation. Its unknown is the power, or the power is the unknown. For example, or first studying this, first we talk about it. If you have, for example, here a to the power m equals a to the power n, if the two expressions here or the two terms are equal, and we have the base equal the base, a equals a. So now I can say that m equals n. For example, if you have 3 to the power n equals 9, I can make this 9 to be 3 power 2. Now I have the same base, 3 and 3. That means n equals 2. If the base equals the base, then the power equals the power. Also here, if you have if the powers are equal, like m and m here, I have two cases. Maybe a equals b. That's correct. If we have here n to the power 5, 3 to the power 5, so n equals 3. And maybe n is, if the power here is even. If the power odd, no problem. But if the power is even, maybe the number here is negative number and the even power cancelled it. Then maybe this number is positive or negative 3. And maybe the power is 0. Because if the power is 0, all the numbers, any number to the power of 0 equals 1. So all the numbers will be 1 at last. So if the power equals the power, maybe the power is already 0. That made the two bases are equal. Like here, 7 to the power n minus 2 equals 5 to the power n minus 2. 7 and 5 are not the same, but n minus 2 is the same power here. That means n minus 2 equals 0, which means n equals 2. Let's solve these examples here about this part. The first one here, in example number 1, we have 2 to the power n plus 5 equals 8. Okay, I can make this 8 to be written as 2 raised to a power. 2 to which power equals 8? It will be 2 to the power 3, yes. Then the base equals the base, that means n plus 5 equals 3. Get the 5 outside, that means n equals 3 minus 5, which is negative 2. That's it. That's the value of n. He didn't ask about solution set, so we just write it like that. Here in number 2, 9 to the power n minus 1 equals 1 over 8. Okay, I can keep this n to be the 9 to be the power n minus 1. 81, I know that it can be written as 9 to power 2. So here it's 1 over 9 power 2. But I need this 9 to be in numerator, like this one. It will be 9 to the power negative 2. Now I have the same base, 9 and 9. Now I easily can say n minus 1 equals negative 2. Get the negative 1 outside, which means here n will be negative 2 plus 1, which is negative 1. And this is the value of n. Let's see number 3. We have 3 over 5 all to the power n plus 2 equals 2 and 7 over 9. I don't have any relation between 2 and 7 over 9 and 3 over 5. So I have to make it as improper fraction. 2 times 9 equals 18. 18 plus 7 equals, yes, 25. So it's 25 over 9. all to the power negative 2. I know that 25 can be 5 raised to a power 2. So it's not the same order. They are not the same numerator, denominator, but they are different here. 25 should be opposite to the 5, not the 3. Then I will flip this fraction. It will be 9 over 25 all to the power of 2. Now the power is positive. Yes, I know that 3 is opposite to 9 here, because 9 can be written as 3 to the power of 2 and 25 can be 5 to the power of 2. All still power 2. Okay, now I have the same power for both of them, 3 over 5. I can make it at 3 over 5 all to the power 2. And it already have power 2, I will multiply them together. 2 times 2 equals 4. So now I have the same base, 3 over 5, 3 over 5, power n plus 2, power 4. Yep, as you noticed, we will say that n plus 2 equals 4. Get the 2 outside, then n will be 4 minus 2, which equals 2. That is the final result for n. Let's see example number 4. We have here 3 to the power 3n minus 6 equals 5 to the power 3n minus 6. Okay, as we said, since the two bases are not the same, then of course the power will be 0. Get the 6 outside. We have now 3n equals 6. Divide by 3. Then n will be 2. Number 5. This is number 4 here. 7 to a power equals 1. Any number raised to any power equals 1 when the power is 0. Yes. So directly I will say that n multiply n minus 3 equals 0. As we used to say in the solving equations, we separate it and we say that n equals 0 or n minus 3 equals 0. From this one we can get its result, n equals 3. So now I have that n may be 0 or n may be 3, as you can see here. Let's see number 6. We have 3 to the power n plus 2 equals n to the power n plus 2. As we said, we have 3 cases maybe. If the power or n plus 2 is even, so we will say that n will be positive or negative 3. And if n plus 2 is odd, we will say that just n equals 3. But if they are not here, if n doesn't equal 3, I will just easily say that, or maybe n plus 2 equals 0. That means n equals negative 2. These are the 3 expectations we can find here. Let's see another part to talk about here. Find the solution set in each of the following. Here it's about the exponential equation already. 18 to the power of n, 8 to the power n, multiply 9 to the power n equals 16. Okay, 18 can be written as multiplication of two numbers. 2 multiply 9 maybe, and they both have the same power n. Because here I noticed I have 9 already, I can cancel them together. But 8, okay, I can make 8 as 2 also, but to the power 3n, yes. To the power 3, and it already have n, so it will be to the power 3n. Then let's finish it first and then put it equals 16. I will cancel this one with this one. In dividing, we subtract the power. It will be 2 to the power n minus 3n. It will be negative 2n. And this should be 16. Okay, we will make this 16 as 2 raised to a power, because the base here is 2. Use calculator to search for 2 to raised to which power equals 16. Yes, it will be to the power 4. Now I will say that negative 2n equals 4. Divide by negative 2, n will be negative 2. Here I have to write the solution set, because he's asking about solution set. Equals negative 2. Let's see another one here. Number 2. 3 over 2 all to the power x minus 2 equals 2 and 1 quarter. As I told you before that, they don't have anything related here, so I have to make this mixed number as improper fraction. So 3 over 2 all to the power x power 2 minus x equals 2 multiply 4 equals 8, 8 plus 1 is 9 over 4. I can make this 9 equal 3 to the power 2. 4 also will be 2 to the power of 2, which is 3 over 2 all to the power of 2 now. They have the same base. Directly I will say that x power 2 minus x equals 2. Yes, it's about to be an equation here, so we have x power 2 minus x minus 2 equals 0. Factorize it, as you used to factorize x and x. 2 gonna be 2 multiply 1 and their difference equals 1, that's correct. And the last term is negative, then the greatest will be like the middle, the other will be with the opposite sign. From here we will say that x minus 2 equals 0, or x plus 1 is the number which equals 0. Using this, here x equals 2 or x equals negative 1. Finally, we have to put the solution set now. Then we have to write it as 2 and negative 1. Let's see the next part here, the last unit and the last lesson, which is the probability. We already talked about probability in many years, in previous years, and in this year also it's not having anything new. First of all, you have to remember that the probability of the impossible event is 0, probability of the certain event is 1, and probability of occurrence of a certain event here, if you want to get that event, the number of times of repeating this outcome over all the possible outcomes. Expected number, that's only the part you are studying more. The probability of its occurrence multiply the total number of the given individuals. For example, here, if one of the factors produces 1,500 electric lamps daily, as a sample of 100 electric lamps was examined randomly in one of the days, 5 defective units were found. We found 5 not working. So 5 were not working out of the 100, not out of the 1,500. So the probability of the defective unit, it's 5 out of the 100, which is 0.05. Yes, you have to remember that we can write the probability as percent. Yes, 5% of the total here is not working. So the expected number of the defective units here, we multiply this probability by the total number of the electric lamps we have. That's how we get the number of expected number of the defective units here. Let's talk more about probability here. Probability of occurrence of an event which is subset of the sample space. It will be number of elements of this event over the number of all the elements in the sample space. As I told you, the impossible event is 0, the certain is 1. Any probability should be between 0 and 1. It can be 0 if it's impossible, it can be 1 if it's certain. So it will be between the closed interval from 0 to 1. So it has no meaning that the probability of an event is more than 1 or 100% or negative number or decimal by negative, anything like that. It can't be possible for us. The first example here, a fair die is thrown once and we observe the number on the upper face. Find the probability of each of the following events. First event here, so we get the probability of A. A is the event of appearance of a number greater than 4. So a fair die, that means all the numbers here are 1, 2, 3, 4, 5, and 6. A number greater than 4, I have only 2 numbers. So it will be 2 out of the total, which is 6. And simplifying it, it will be 1 out of 3. And this is number 1. So let's see number 2, probability of B. B here is the event of appearance of an even number. The even numbers 2, 4 and 6. They are 3 out of the total, which are 6. Dividing by 3, it will be 1 out of 2. Put it in simplest form. Don't forget that. Number 3, probability of C. C is the event of appearance of a number 5. Okay, I don't have any 5. It's only one 5, so it will be 1 out of the 6. Number 4, probability of D, which is the event of appearance of number 7. I don't have any 7, then it will be 0 out of the 6, so it will be 0. The last one here, number 5, probability of E. E is the event of appearance of a number less than 7. Less than 7, I already have all the numbers are less than 7. So it's 6 out of the 6, which is 1. So here this is an impossible event and this is a certain event. Let's see another exercise here. A bag contains an amount of marbles of the same size and softness. If 2 marbles are red, 3 marbles are blue, 5 marbles are white, a marble is drawn randomly, calculate these. So first of all, I have to put them in front of my eyes. 2 are red and 3 are blue, and also we have 5 are white. Don't forget to put the total for them. Their total equals, yes, as you counted them, 10. I will use the total and I will use each number alone here. So first of all, let's get number 1. Probability that the drawn marble is red. The drawn marble is red, we have only 2. So its probability here will be 2 out of the total, which is 10. Simplifying it, it will be 1 out of 5. Number 2. Probability that the drawn marble is blue. Okay, the blue marbles here are 3 and their total is 10. It can be simplified. Then in number 3, the probability that the drawn marble is white. White means 5, so it's 5 out of the total, which is 10. Simplifying it, it will be 1 out of 2. The last one here, number 4, probability that the drawn marble is not blue. Not blue means I will cancel the blue out of the total. The blue is 3. Then the remainder here are 7, so it will be 7 out of 10. Or we can make it as 1, which is the whole number for all the probabilities here. The sum of all probabilities is 1 minus the blue. Because he need the not blue, I will subtract the blue from it. Okay, the blue, it was this one here, 3 out of 10. Which will give me the same result, which is 7 out of 10 also. And that's it here. Thank you for watching this revision. Wish you enjoyed and wish you were interested in watching it. See you next time, inshallah. Thank you.